Because the math is bananas. B-A-N-A-N-A-S. Yo, welcome children. It's another pre-calculus honors lesson with your favorite balding and chubbying math teacher, Mr. Berto. That's a true statement right there, maybe with the exception of the word favorite. Little do problem here, so why don't you copy that down, pause this and try it in your notes. And we want to find the area of region R. And here we have y equals cosine x. Remember, if you want the area between a function and the x-axis, we want to integrate that function. So you want to integrate cosine x with respect to x. Make sure you put that dx. But we need bounds. And some people are like, well, how the heck am I supposed to figure out what the bounds are? Well, don't forget Mr. Berto's impersonation of the cosine curve from 0 to 2 pi. Here, what the cosine curve would look like. A little something like that from 0 to 2 pi, right? Here's my impersonation. This right here is really just pi over 2, and that's actually my upper bound, right? And this guy right here would actually be negative pi over 2. So with the knowledge of the basic cosine curve right there, should be pretty easy to figure out what the bounds are, okay? Also, don't forget about that trick from yesterday. This negative pi over 2 looks kind of nasty. Let's start at 0 and go to pi over 2. And that means we're actually getting half of the area. How do you make a half into a whole? You multiply by 2, because 2 times a half is equal to 1. The number of cookies I cannot stop at eating. So here, what do you think about that setup? Can you do this? Can you figure out those bounds? Some people are like, yeah, I understand the setup if I knew the bounds. Well, that means your calculus is not an issue. That means your algebra 2 trigonometry is an issue. What a surprise, okay? We spoke about it plenty of times earlier in the year. People do still struggle with it, so make sure you work on that. If you got a good knowledge of trig, it's going to be so much more powerful in calculus than other people taking the AP exam. Anyway, now we can have some fun. 2 times, let's integrate cosine x. In a world of integrals, cosine x is the good guy. He's realized the error of his ways. I don't want to sell death sticks anymore. A little prequel meme right there. So the integral of cosine x is sine x, evaluated from 0 to pi over 2. Once again, you could leave the 2 outside, or you could actually leave it attached. I think I pulled it outside in yesterday's problem, one of yesterday's problems. Let's leave it attached. Make it 2 sine x, so 2 sine of pi over 2, minus 2 sine of 0, cedo. All right, and that's going to give us 2 times, if you don't know what the sine of pi over 2 is, slacker, minus 2 times sine of 0, which is 0. So we end up with an answer of 2 right there. Lots of things coming into play besides the calculus. The calculus is just the setup. The rest of it, trigonometry, algebra, obviously the calculus for the integral as well. Hopefully not too terrible. I hope you're practicing these things, okay? If you got stuff going on at home, I understand, okay? But don't use distance learning as an excuse to not do anything if your life is okay right now. What you could have done this. Remember that area between 2 curves forming a little star action? Star! What's that word? Starts with R? Recall. Area between 2 curves. Area between 2 curves. I should have been a singer. A singer. Area equals the integral. Remember, x sub 1 to x sub 2. So x bound to x bound of upper function minus lower function with respect to x. This bothers people. They're like, Berto, why are we using the area between 2 curves formula here when this is the area between a function and the x-axis? Well, guess what? The x-axis is a function, okay? He is a curve with 0 concavity. Here's the curve y equals 0. So believe it or not, you could use upper minus lower here. You could draw in that sample rectangle. Remember, we only draw 1, but we imagine like an infinite amount, or like 7. And you can see throughout this entire region, the upper function, no matter where you put that rectangle, right? Usually on the smart board, I take the rectangle, I move it back and forth. I can't do it. I don't have a smart board. No matter where you put the rectangle, you'll see the upper is always cosine x, y equals cosine x. The lower is always 0, y is equal to 0. You could use the upper minus lower formula here. Seems silly. Area is equal to the integral, so you could do this as well. The bounds be the same. Hey, leftmost x value to rightmost x value. The leftmost x value here is negative pi over 2. It's the leftmost x value of the region up to the rightmost x value of the region, pi over 2. They're not intersection points this time. Well, I guess they are, okay, but there's zeros as well. Upper function minus lower function. Upper function is cosine x. Lower function is 0. Integrate it with respect to x. And you can see this is the same as what we started with, right? Because cosine x minus 0 just equal to cosine x. So people are like, yeah, that's dumb. And I remember that the first time I saw it too, and a teacher showed me it that way. I was like, that's dumb. I'm going to do it this way. Whenever you want the area between a function and the x-axis, just be careful this will always give you area. You know, only when the region's above can you just take the integral of a function to get the area between the function and the x-axis. If the region is below or partially in between, it's not going to work anymore, okay? But this will always give you area every single time. That's why it's the area between two curves formula. So this might seem extremely silly right now, but I want you to do it, because when stuff gets a lot more complicated with volume and stuff next year, this is going to be useful. So drawing that rectangle might seem dumb to you, and setting it up like this might seem dumb to you, but that's something I actually want you to try, okay? So try to get used to it. I'm trying to train you in a specific way. There are many ways to do these problems. Some people are like, I'll just go online, watch some video. I like the way this guy did it better. I'm training you to do things in specific ways for specific reasons, okay? It doesn't mean you can't go outside of my scope of what I'm trying to show you. I applaud that, okay? I want you to try to do things like that. But also, I try to teach these things in the simplest way possible so I could draw connections later on in the curriculum as well. So really a steady mix of both is the important thing. Did you try that homework? Okay, you know, as far as the homework was concerned, you're allowed to use the calculator here. The area between two curves formula should be easy. It should be easy to figure out which is upper, which is lower. Make sure you have those parentheses. Lower bound here was 0. Upper bound, I actually set these equal, and I got the bounds that way algebraically, but you could have just put this in the calculator, calculated the intersection point, get the x value, calculate this intersection point, get the x value. We'll do that next lesson. We'll do more with area between two curves with the calculator. So here, if you did it this way, it's great, really. It's kind of annoying. You could use the calculator as well. More on that next week. 15, really cool problem. Oh no, I speak on. Sorry, I'm just looking at my notes. So I want to say anything else? No, I guess we talked about all these things. Maybe just one little thing about this portion being below the x-axis of the region, but it does not matter when you use the upper minus lower formula, always going to give you area. 15, there's some interesting things to speak about with no calculator. Should be easy to graph. Whenever it's no calculator, it should be functions that you know how to deal with for the most part. You could graph this without a calculator. These are just extremely annoying. And over here, y equals x squared and y equals x. If you can't graph them, it really scares me. But just be careful with your concavity here, because it might be hard to actually see what the region is, okay? You know, and some people even do this. They're like, okay, I want the area between two curves. So area is equal to integral. Then they're like, let me get the bounds, okay? And then they actually set them equal, okay? Which is what I did here. Get the bounds, you get 0 to 1. So it's easy to do bounds without a calculator, right? You know, if you know your algebra. Upper and lower without a picture. Like, you know, how do you figure out which is the upper function, which is the lower function? The functions always represent y values. So what you could do, you could pick an x value in between 0 and 1, maybe pick 1/2, plug 1/2 into both of the functions, okay? You know, we have y equals x squared, and we have y equals x. And if we say x is equal to 1/2 here, well, y equals x squared becomes y equals 1/2 quantity squared, which is 1/4, right? And here we get y is equal to just 1/2. So look, you can see that this right here is a bigger y value. And this one right here is the smaller y value, smaller y value. Okay, and that means that I know y equals x is the upper function because it gives me a bigger y value when I plug in a number in between the bounds, and y equals x squared is the lower function because it gives me a lower y value when I plug in an x value in between the bounds. That's very antiquated these days, okay? And sometimes not even useful because there's other types of problems where there's multiple regions and such, so it only works for simpler types of problems. But I thought I'd mention it because you never know when something like that's going to show up, and something you normally do doesn't work. So that's the thing about calculus. Some people are like, well, I understand the problem this way, so I'll just keep doing it this way over and over again. But something's going to show up at one point in time where you can't do what it was that you wanted to do, whether it's some kind of algebraic manipulation you can't perform, some kind of equation you can't handle, some kind of numerical, approximation you can't handle. You might have to do something in a different way. This is all about giving you more and more ammo to put in your clip so you could blast away these calculus problems when you need to. So that's one way to be like, oh, I know the upper function is x and the lower function is x squared integrated with respect to x. And that's what we call eloquence, okay? Doing the entire problem without actually thinking about a graph. Technically, you just think about this graph because it's really simple. But when problems are more complicated, this becomes more useful. You could have used it for this one right here, right? Set them equal. It's actually not that bad to do. It's just annoying. Then plug in like a 1 to each of them, and you'll see this guy's the upper, this guy's the lower. Pretty useful technique right there, okay? So a lot of things to actually speak about. And I think that's all I have to say about that. Okay, so look, don't forget, really focusing on two things primarily in this topic right here. Area between a function in the x-axis or area between two curves. They're the same thing because the x-axis actually represents a function. Also, we've been talking about definite integrals, okay? You know, definite integrals that need U-substitution, definite integrals that don't need U-substitution. So we're just going to do some interesting integrals here. You see in each of our lessons, there's going to be a couple interesting integrals. The first one you might not call interesting, you might call completely disgusting, okay? But it's not because of the calculus. You know, the calculus here, you know, first off, how do you integrate something like this? It's all about integrating. People look at it, they're like, it looks so small and insignificant, it must be easy to do. But it's not. It's a filthy integral. Some people are like, I'll just cancel out the e to the x's. That's easy. Yeah, and then please check yourself into another math class because you're totally wrong. You know, remember, coronavirus, a lot of things have been canceled. They're canceling everything. But you know what doesn't cancel? E to the x and e to the x right here. Can't cancel over addition. How about this? You could use U-substitution, by the way. And I think the only variable u here is 1 plus e to the x. And you'd be right if you set that equal to u. But how about this? You're integrating a quotient and the bottom's not being raised to a visible power. Just because it's transcendental here and it's not algebraic. Remember, if you're integrating a quotient, bottom's not being raised to a power, take the derivative of the bottom. And you should know the derivative of 1 plus e to the x is really 0 plus e to the x, which is just e to the x. And check it out. That e to the x is chilling out up top there. So remember, whenever that happens, the answer is going to be ln, absolute value of the denominator, normally plus c, in this case evaluated from -1 to 1. Do you remember that trick, the ln trick? You could use U-substitution if you want. You have to change bounds, okay? Things get slightly more snarky, because if you said u equal to 1 plus e to the x, then when x is equal to 1, u is equal to 1 plus e, so the bounds get weird right there, but it would still work. The mental integration, really useful. The ln trick, if you're integrating quotient and the bottom's not being raised to a power, I hope you're thinking about stuff like that. Some people are like, yeah, about those bounds, Berto, I'm going to take this -1, make it a 0, and put a 2 in front. You can only do that if there's symmetry. Symmetry, okay? You can't just do that in any type of situation. And people are like, well, maybe there is symmetry. Well, do you know what this graph looks like? Neither do I, okay? So we're not even going to focus on it that way. We're going to do it this way. Let's plug in that upper bound. You get ln absolute value of 1 plus e to the first, so 1 plus e. See, there's that 1 plus e that you get if you change the bounds anyway. It's not as bad as you might think. Minus the plug in the lower bound, ln absolute value of 1 plus e to the -1. You know, and then, what do you do? You know, the calculus is not difficult here. The calculus is easy. You're done right here with the calculus, you know, and now you have an answer, but you won't see it in multiple choice. So the algebra here, the transcendental algebra, is what gets a little bit weird. You read what I'm writing right now? I just put e to the -1, made him 1 over e. 2 ln's, maybe you start looking in multiple choice, you know, to get like a clue, like how the heck do I do this? A clue! You know, put it in your notebook, because they're whose clues? Blue's clues. Anyway, you might see only 1 ln in the answers, and then you're like, wait a second, if I have 2 ln's, how do I condense them into 1 ln? This is me thinking right here. Well, if you have 2 ln's connected by subtraction, you can condense them into 1 single ln if you divide the arguments. All right, so that's the first part that bothers some people. Usually I give this, problem out in class. I just let people work on it for a little while. And a lot of people, once again, can get this far. Then the algebra bothers them. This is a complex fraction inside here. Something students used to be great with because they actually taught it in Algebra 2. Then Common Core came along and was like, no, let's get rid of stuff that's useful in mathematics. You know, and they don't really teach this in Common Core anymore because apparently you don't need it for calculus. Wrong. Here it is. Here's the easiest way to do it. If you reason it's a complex fraction, you have fractions inside a bigger fraction, okay? This 1 over e, if you actually multiply him by e, the e's will cancel out. But this is the most illegal thing I've ever seen in my life right here. Okay, you have to multiply the entire denominator by e and the entire numerator by e as well. Okay, so just some algebra here and a little antiquated too. Try not to freak out if this is bothering you. You could write this as e plus e squared, but I'll just write it as e times the quantity 1 plus e. So I put the e in front. So what? Same thing. Distribute this e times 1 is e, plus e times 1 over e is just going to be 1. And now you can see what happens. You know, if you don't distribute this e inside here, you can see 1 plus e and e plus 1. They cancel. They're the same thing. So we really end up with the ln of the absolute value of e. Remember, e is approximately 2.71, yada, 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 Euclid's number. It's positive, which means it's absolute value. Just drop the absolute value signs to take it. And perhaps you remember the ln of e is equal to 1. How amazing is it that we end up with an answer of 1 right there? Filth, froth, frothy, snarky, okay, and antiquated. So don't worry about it so much. Stuff like this can still happen, okay? In this class, and next year's class, not just about AP calculus, it's about all calculus beyond that, okay? And there'll be a time where suddenly you gotta do some integral and weird stuff like this happens. Maybe you think to this moment. But once again, it's not the calculus here that's difficult. It's the manipulation. The exact opposite of number 2, which you could try on your own. You know, here it's the calculus that's difficult, and afterward, the the algebra piece of it is not too bad. Like, how do you integrate this thing? Once again, it looks kind of simple, okay? But, it's not basic integration, okay? You see the division right here. This dx being up here, they really like to mess with you. The dx, you could always pull it to the side, not outside the integral. Just pull it a little bit to the right. And that leaves us with x ln x downstairs. Put the dx here. Can't leave the upstairs empty, right? So we got to put a 1 right there. Whenever you see that, they'll like the dx to get involved sometimes. They'll put them in different spots in the problem. Always just pull them to the right, okay? Don't let that bother you right there. This is hard enough to integrate as it is. You can be like, hey, you're integrating a quotient. The bottom is not being raised to a power. You can take the derivative of the bottom. Excuse me. You need to use the product rule. And there's no way you're multiplying it by a constant to create the top. Okay, so it's not that type of ln. And there's division. Okay, so it's not basic integration. Algebraic manipulation is what you actually want to do here. You can pick a u. If you set u equal to x ln x, you still end up with the same issue. If you set u equal to ln x, u equal to ln x, will it get you anywhere? It actually will if you set u equal to ln x in this particular case. I'm going to do this, okay? I'm actually going to bring this x upstairs. And look, people are like, I wouldn't have thought to do that. Now he's x to the first, now he's x to the negative 1 upstairs, right? And look, it's not about thinking to do that. This is what integration is. There are weird things that happen. You just got to play around and mess around. It's not always going to be an obvious answer to a problem. Some people are like, wow, great, Burrow, that really helps me. Well, it does. If you actually do the integral from e to e squared, x to the negative 1 is really 1 over x, right? And now it is the classic ln situation. Trying to integrate a quotient. You can see the bottom's not being raised to a power. Let's take the derivative of the bottom. Do you guys remember what the derivative of ln x is? That's right, it's 1 over x, and it's chilling right there up top. Whenever that happens, the answer is ln, absolute value of the denominator, usually plus c, in this case evaluated from e to e squared. So it's an ln inside an ln. It's like a whole inception thing. You guys even know about that movie anymore? Great movie, by the way, Inception. Here, so the calculus might bother you, right? Just getting to this point. Hopefully this is okay to understand right here. If you did set u equal to ln x right away, you would end up in a decent situation. You'd end up with an x upstairs to cancel the x downstairs. Try it out, okay? It's actually not too bad here. Now I'll plug in ln absolute value of the ln of e squared minus ln absolute value of the ln of e. People are like, I can't believe there's ln's and e's. That's horrible when that happens. No, it's extremely easy because the ln of e squared is just 2. This is really ln absolute value 2. Minus the ln of e is just 1, right? So the ln absolute value of 1. Look at how terrible that is. It's so dangerous. It looks like ln 111. So maybe I'll make my 1 right there. Regardless, you could just drop the absolute value for both of these, right? The absolute value of 2 is 2. The absolute value of 1 is 1. And now we know the ln of 2 is just the ln of 2. It's irrational. Minus the ln of 1, which is 0. So we just get an answer of ln 2. So hopefully getting the answer here, not too horrible. You got to play around. I know transcendental stuff, ln's and e's, people don't love them. They don't go ee when they see them. But you should, and you should become comfortable with them. Just like with trig, it's one of the reasons people struggle so much in calculus. People struggle with transcendental stuff. They struggle with trig. It's hard. The struggle is real. It's not easy, but you'll get past it if you just put in your work. I'm telling you, put in your work. You'll see certain types of things repeat. You'll get more and more intuitive. That's what you want to do as a calculus student. It's not just a class you want to cram. I get it. You might be like, well, I'm cramming everything this year. I still get 95s. This is not AP. This is pre-AP, okay? It might be a different situation for you next year. So cool problems here. That's where we're going to end, okay? So remember, we're talking about area between two curves. We're also talking about area between a function, the x-axis, same as area between two curves if one of the curves is y equals 0, and just some abstract definite integrals, okay? You've got to get used to integration. You got to practice. Do the best you can. Please try your homework tonight. I don't think it involves any of these. I think it's just area between two curve types of problems, but take a look at these. Make sure you don't forget about them. You will see some like them on your assessment. I think I'm going to give you Thursday and Friday of next week to work on. And then we'll have 3 weeks of school left. The last week will probably be summer assignment. The week before that, we'll do final review. Probably just a week where I'll give you a review sheet and have you guys work on it and give you the problems. So probably no videos. The week in between, I don't know if I'm going to do videos or not. I'm not sure yet what I'm going to do. Maybe we'll do some Raymond sums and stuff like that. Anyway, I hope everybody's doing well. Okay, if you need to get in touch with me, please do email, remind. Miss all you guys. Okay, obviously we won't be seeing each other until next year. Be prepared. Be ready, okay? Next year, hopefully we'll be able to see each other right away. You know, there's all kinds of different things that they're discussing. Maybe half people in school one day, half people in school another day, supplement with videos and stuff like that. Make no mistake, I'll do the best I can to get you ready for that advanced placement exam if you take AP Calculus, but the onus is on you, okay? You have to be willing to actually put in the work. And you guys are awesome, really a great group. So I'm not really worried about it, with the exception of like 2 or 3 people. Anyway, so that's it for today. Have a happy and a healthy and a good weekend. Berto, see you on Monday. Adios.